Hello and welcome to another Orange Coast College Mathematics video. In this video, we're going to learn to multiply polynomials like this one here. Now before we begin, I'll assume you're comfortable multiplying monomials together, that is, polynomials that have only a single term. Here's our first example. Now we want to multiply, we have a product here of two binomials, that is, two polynomials, each with two terms. And the way we need to distribute this product is we have to multiply each term in the first by each term in the second. So every possible combination. And the way we can do that is, or a way we can help remember how to do it, is what's called the FOIL method. And it stands for first, outer, inner, last. So we multiply the first terms together, then the outer terms, then the inner terms, and then the last terms. Okay? So we'll do the first, which is 2x times 3x. That gives us 6x squared. And then we'll do the outer terms, okay, which is going to be 2x times negative 5y. It's going to give us negative 10x times y. And now we do the inner terms. Y times 3x is going to give us positive 3xy. And then finally, we do the last terms. Y times negative 5y gives us negative 5y squared. And the last step here is to make sure we can simplify. So you'll notice we have two like terms here. Each of these terms have an xy as their variable, which means we can add them together. So we have negative 10xy and then 3xy, so that's going to give us 7xy. So we end up, or negative 7xy. So we get 6x squared minus 7xy minus 5y squared. And that's it. In this second example, we have a product of two binomials, but unlike in the first one, each binomial has the same, almost the same two terms. We have 4u plus 3, and over here we have 4u minus 3. So when you have a binomial where the only difference is that the second term, or that one of the terms has a different sign, we call these two binomials conjugates. And so to multiply them together, well, let's just do it. And then you'll see a sort of an interesting thing happen. So first we do the first terms. So 4u times 4u, that will give us 4 times 4 is 16. U times u is u squared. And then the outer will give us 4u times negative 3. So 4 times negative 3 is negative 12. And then you have a u factor there. And then we do the inner, okay, 3 times 4u. 3 times 4 is positive 12. And then we have a factor of u. And then the last, we have 3 times negative 3, which is negative 9. And you'll notice now we have to simplify this when we're done. You should always be simplifying after you've multiplied out polynomials. Make sure you can simplify. But we notice we have negative 12u and positive 12u. When I add those two together, they will cancel each other out. Okay, and we're left with just 16u squared minus 9. And so this is actually what's known as a difference of squares. And so we could have saved time rather than using the FOIL method here if we just realized we have this pattern where these two are conjugates by simply taking the square of the first term. So we just square 4u, take the square of the second term, which is 9, and then take the difference. And that'll be true anytime you're multiplying conjugates together. Here's our third example. We have the binomial 3x minus 4 squared. Now it's important to understand that this just means 3x minus 4 times 3x minus 4. Now, like in the last example, there is a pattern here, but let's use the FOIL method, and then we can see if we can understand the pattern at the end here. So we first have the first terms, 3x times 3x. 3 times 3 is 9, and then I will have x times x is x squared. And then the outer term, so 3x times negative 4 gives us negative 12x. And then down here, we have negative 4 times positive 3x, that's also negative 12x. Okay, notice that unlike in the last example, these terms have the same sign and won't cancel out now. And now we have negative 4 times negative 4 for the last. That is positive 16. And so we get 9x squared minus 24x squared plus 16. And again, we should check to see, can we simplify this? And the answer is no. But you see the pattern here, because we're going to end up multiplying 3x and negative 4 together twice, right? 3x times negative 4 when we do the outer terms, and then we do the inner terms as well. We get negative 4 times 3x. We end up having 2 of these terms. So you don't really need to multiply this all out and FOIL it. You just take the first term squared, 9x squared, the second term squared, that's positive 16, and then you just take twice the product of the two terms. That's what this negative 24x is, right? 3x times negative 4 is negative 12x, but you're going to double it because you're going to have 2 of those terms. So if you wanted to, you can write this down. If you have a plus b and you square that, okay, it's going to be the first term squared plus twice the product of the two terms. So twice a times b, and then plus the second term squared. And that's it. Here's our final example. Now, unlike the previous examples where I multiplied two binomials together, we have a binomial times a trinomial now, trinomial being a 3-term polynomial. The FOIL method doesn't quite work, but the idea behind it is the same. Each term in the first must be multiplied by each term in the second. Now, with polynomials like these, where it's each term is like a descending power of the variable. So this is like a to the first. This is a constant term, but you could think of a constant term like a to the 0. So it's a to the first, a to the 0. Over here, this term is a squared, a to the first, a to the 0. When you multiply the first term by all of these, write them in sort of one row here. So first we'll have a times a squared. That will be a cubed. Then we'll have a times negative 2a. That's going to give us negative 2a squared. And then finally a times the constant term. So that's going to give us a times 4 is positive 4a. Okay. When we do the second term, this is assuming that everything's written, again, in descending order. Okay, when we do 2 times each of these, write them below, but write them one term to the right. You'll see what I mean here. You don't have to do this, by the way. I think it makes it easier. So we have 2 times a squared. That's going to give us 2a squared. But instead of writing it underneath a cubed, I'm going to write 1 to the right. So it's going to be 2a squared. And now I do 2 times negative 2a. That's going to give me negative 4a. And then finally, 2 times 4 is 8. And the reason why we did this, okay, is because if you look at these, just the terms we have, they all match their type. They're all like terms, right? So it's a cubed, there's no other a cubed term, but you have a squared terms, a terms, constant terms. And so now just sort of add them up. You have a cubed, you have negative 2a squared plus 2a squared is 0a squared, okay? Then you have, so these cancel each other out. Then you have 4a minus 4a, those also cancel each other out. And then finally you have 8 plus 0. So this ends up just being a cubed plus 8. And it turns out this was actually a special product that gives us a sum of cubes, right? Because a is a cubed, and then 8 is 2 cubed. And so you could factor this. This is sort of a way to get back to here is by factoring this if you know that formula. If you're interested in that, we have a video on factoring sums and differences of cubes. In any case, though, that is multiplying polynomials. Again, if you practice this, I'm sure you'll pick it up in no time. Until next time, have fun.